So for the rest of these problems that you see here on the Fundamental Theorem of Calculus page, we're going to do a few of them, but before we do them, I thought I would go ahead and give you guys some formulas for the antiderivatives so we didn't have to continue to work so hard for those. If by chance your lowercase f of x is x to the nth power, then an antiderivative that you can use would be x to the n plus 1 divided by n plus 1. This is the reverse power rule, okay? And we should also keep in mind the reasons for these. And maybe it'd be good to put another column. This would be the reason column, okay? So the reasons why these capital F of x's are the antiderivatives is because the derivative of them, derivative of x to the n plus 1 over n plus 1 is equal to n plus 1 times x to the n plus 1 minus 1 all over n plus 1. So it gets really messy. Nevertheless, the n plus 1's cancel out, the 1 minus 1 cancel out, and you just get x to the nth power, which is what we have here. So when you see x to the n as the integrand, you just add 1 to the exponent and then divide by that exponent plus 1 as well. Okay. So you may be able to figure this one out on your own. What's the antiderivative of the sine of x? Well, that would be not the cosine of x, but negative cosine of x. So the antiderivative of negative cosine is the sine, because the derivative of negative cosine is the sine of x. Okay? Remember, derivative of the cosine is negative sine, but if minus sign there, cancels out the minus sign there, and you just get sine of x. Okay? What about the antiderivative for the cosine? The derivative of what is the cosine? And hopefully you answered out loud, derivative of the sine of x is the cosine. Okay? And then the derivative of what value or what function is the secant squared of x, and that would be the tangent of x. The derivative of the tangent is secant squared. Derivative of tangent is secant squared, and the derivative of sine of x is equal to the cosine of x. Alright, so if you keep that in mind, then keep those rules in mind, then these problems are not that bad. It's just a matter of keeping your math straightened out here, and then actually rewriting the integrands in a more convenient way. Let's rewrite this integrand, still 0 to 9, but we're going to write that as x to the 1/2. Okay, because the antiderivative of x to the 1/2 is x to the 3/2 divided by 3/2, because 1/2 plus 1 is 3/2. But we don't like this either. Okay, that's evaluated from, again, from 0 to 9. But also then we'll write down, if you divide by 3/2, it's the same as multiplying by 2/3. And what I'm going to do is I'm going to factor out that constant and then just leave the x to the 3/2 inside. Now, when we have a constant out in front, that's when we'll put brackets around, okay, around the antiderivative. Notice over here we have the antiderivative not surrounded by brackets, but just, here's the antiderivative, and then there's just one line, okay? That's because there's no constant out in front. Same thing over here. We have the antiderivative and then the line, which then shows what the upper and lower limits of integration are. Same with over here. Okay. And then over here, though, we have this constant out in front, so we're going to bracket our antiderivative and then evaluate it at the upper and lower limits of integration, and then follow that by multiplying through by the 2/3. Okay, so we'll keep the 2/3 out in front while we do the rest of this. So the 2/3 out in front, and then this stuff here means we're going to substitute 9 for x. We get 9 to the 3/2 minus 0 to the 3/2. So that's kind of nice when we have a 0 there. 0 to anything is just 0. So this is equal to, and then equal here 2/3 times. What's 9 to the 3 halves? Well, it's the square root of 9, which is 3, to the 3rd power, which is 27. So 9 to the 3 halves is 27. Well, if you want to, you can do 9 cubed first, and you can get whatever that is, 243, and then take the square root of that. But I would much rather keep my numbers a lot smaller, and hopefully you would as well. It's easier to make mistakes when the numbers get bigger. But 3 goes into 27 9 times, and 2 times 9 is 18. Okay, so that's kind of an interesting concept, that we can even find the exact area, and it's not a bad area. It's it's an easy, nice whole number there. If we look at this problem up here, what we're really doing is we're finding the area between the curve radical x and the x-axis on the interval from 0 to 9. So that's kind of a cool thing. And I want to show you one more thing with the calculator. Another way to find the area there, the integral. Okay, so that integral has a value of 18. So let's look at our calculators again. And this is really kind of cool. Usually I hear noises from students when I show this, so I'm a little sad that I don't get to hear that from you right now. Like, oh, okay, so maybe let me know in class if you actually do make a noise when you see that, when you see this. Okay, so we have the integral of radical x. So remember, this is the graph of y equals the square root of x. Okay, and we're going to do that. We're going to graph that radical x. Okay, and I guess I didn't need that parentheses there. Delete that and get out of there. Okay, so we have our square root of x defined as our y1, or vice versa, and then we're going to graph it. But first, we're going to adjust our window. We're going to go from 0 to 10 in the x direction, and we're going to go from let's do a little bit less than that, -1 to well, the square root of 10 would be a little bit more than 3, so let's go to 4. And let's actually adjust our 0 to -1 so we can see a little bit more of that. And then I'll adjust my x res to 1, and then graph. And so you should have a graph that looks like that. Okay. And then we're going to evaluate the integral. Remember what we found? I don't. Okay, it's 18. And follow along with me here. Do second, calculate. So the trace button, when you put the second first, is CALC above that. So you should know that. And then notice there that number 7, the integral of f of x. Lower limit, we're going to type in our lower limit of 0. Enter. Our upper limit, remember that's 9. X equals 9. Enter. And ooh, look at that. And you say, hey, Mr. Hawks, that says 18.000045. Well, guess what? When you round that number to the nearest 3 digits after the decimal, it is 18. And so sometimes, though, you know, your calculator will give you kind of a weird number like that. Nothing to be alarmed about. Just round it to the nearest 3 digits after the decimal, and you are fine. And another note on that, calculators are based on approximations, and so sometimes it gets a number in there and somebody else's calculator might give them something different. Your calculator might not look like that. Yours might just say 18. Nevertheless, the area under the curve is 18. So that's kind of a cool thing. And again, we could do math 9, okay, and go from 0 to 9, our y variable y1 dx, and enter, and we'd get 18. It's probably just going to say 18. Oh, there it has a different number. So that is in essence 18, which is exactly what. So actually, if you got 18 and the calculator got 18 point all these zeros and then a 2.5, you're smarter than your calculator, because 18 is the exact value, and this extra stuff out here is just a mistake by the calculator. It can't get you the exact value. Okay. So that being said, if you have the gumption, go ahead and try number 4 on your own, and check on your calculator, check back with me, whatever you desire to do. But I would caution you, though, about jumping right into this, here's a way you can make this a lot easier on yourself. 5 to 10 of 2x to the negative 2 over 3 dx. Here's another little trick. It's not really a trick, but it's something very helpful. Notice 2/3 times the function there. We can bring the 2/3 out in front of the integral symbol and then integrate from 5 to 10, and we can integrate x to the negative 2 dx, which makes that a lot better. And we're going to go way over here. Okay, and so I'm going to leave the 2/3 out there, put brackets because we have a constant out in front. We use the reverse power rule, x to the negative 2 plus 1. Think through these. Plus 1, negative 2 plus 1 is negative 1, and we're going to divide that by negative 1, evaluated from 5 to 10. But I don't like that negative 1 there, and I don't like my negative exponent when I'm going to start plugging values in. So I'm going to bring the negative 1 out, and I'm going to make that a negative 2/3. And then I'm going to rewrite x to the negative 1 as 1 over x. Okay? That's a lot simpler. Okay? So we have negative 2/3 multiplied now by the quantity 1 over 10, so the antiderivative evaluated at the upper limit, 1 over 10, minus the antiderivative 1 over x evaluated at the lower limit, which is 5. So if you really want to continue with this, we can. If you don't, just fast forward. If you know, if you don't want to work your way through that. But I would write negative 2/3, 1/10 minus 2/10 is negative 1/10. The 2 cancels with the 10, you get 5. Negative times a negative is a positive. And so we get positive 1 over 15. And if I made a mistake, I apologize. I got kind of, I don't know, I didn't get rushed there, but there's a lot of areas to make a mistake. But nevertheless, that would be how you find your answer. And I guess what I'll do here is, I don't know if I can fit this last one in. I guess I will try. 2 plus sine of x. The antiderivative of 2 is 2x. The antiderivative of sine is minus cosine, evaluated from 0 to pi. So we get 2 pi minus cosine of pi minus 2 times 0, not 0, minus cosine of 0. Well, if you're anything like most students, you're either going to make a mistake this first time on the cosine of pi or the cosine of 0 or the minus sign in front of one of these. So if you got this far, then you understand the calculus. If you don't get the right answer, then you forgot the algebra / trigonometry. Okay? So I'm going to write 2 pi minus, I'm going to use parentheses because I'm a good student. Cosine of pi is negative 1 minus 2 times 0 is 0. We have a minus sign in front of cosine of 0, which is 1. So I have 2 pi minus minus is plus plus, minus minus is plus plus. So we have 2 pi plus 1, which is plus 2. Okay, let me quickly do that on the calculator so I can confirm to you what we got is actually the correct answer. If we substitute for the y1, we're going to type in 2 plus sine of x. By the way, anytime I do trig, I make sure that I have my mode selected as radian mode. Okay, so anyway, we've got our y1 already set, and we're going to do second enter, and we're going to do y1 there, but we were going, remember, from 0 to pi, pi, which would be second pi right there, and then we're going to enter, and we get that, which if you subtract 2 pi, subtract 2 pi, we should get 2. Okay, and there you go. So in other words, 2 pi plus 2 is equal to the 8.2831 blah blah blah. Okay, so we can confirm that we got the right answer, which is 2 pi plus 2. I'm almost out of time. I will see you in class.